In the past, when navigation was less accurate, there was an inbuilt element of randomness in the distribution of aircraft around a track. Perhaps surprisingly, this added to safety. It was less likely that two aircraft would collide if one should inadvertently fly at the wrong flight level as a result of error or turbulence. Now that systems have become so accurate, particularly using GPS, this added element of safety disappears. In this situation, these three aircraft are all flying along the same track, but navigational inaccuracies distributed them randomly. An aircraft flying the same track in the opposite direction is at the wrong level and is in conflict with the others. However, because none were flying the track with absolute accuracy, there was no collision. But consider this. With the extremely accurate navigation systems now in use, all the aircraft fly exactly on the centre line of the track. This means that collision is much more likely should an error be made. So you can see how accuracy reduces safety in this case. The following clip demonstrates a procedure introduced in 2004, the special lateral offset procedure that brings back some of the randomness that enhanced safety. The special lateral offset procedure, called Slop, requires pilots to decide either to fly on the centre line of the track, or 1 mile to the right or 2 miles to the right. They should make this decision on a random basis, while taking into account any wake turbulence being experienced. If another aircraft is at the wrong altitude, then the chance of collision is reduced by a factor of almost 3. While opposite direction traffic is infrequent, the Slop procedure is also effective for the more likely conflict with same direction traffic at same level. If severe turbulence causes an aircraft to change levels violently, then Slop makes it less likely that there will be another aircraft immediately above or below. So Pete, Slop is a pretty effective strategy to reduce risk.
Yes, it is. However, radar observations show that crew are rarely adopting offsets, and probably only when avoiding wake turbulence. It's important that pilots adopt this procedure as a matter of course, for risk reduction rather than just for comfort. Perhaps each captain should make up his own rule, something that's going to be personal and truly random. In any case, for 2 flights out of 3, the captain should be offsetting.
So do you feel comfortable flying off track?
I am now, but to start with it did feel very alien, very strange to fly 1 or 2 miles right of the centre line without an air traffic clearance.
What about you, Graham?
Since the procedure has been introduced, I've devised my own system whereby 2 out of 3 times across the Atlantic I flip a coin to decide whether to fly 1 or 2 miles right of the centre line.
Patrick Coleman, an oceanic controller from Gander, joins us by video link. Patrick?
More of a concern is that we have observed aircraft offsetting to the left of the track. This increases the risk with opposite direction traffic. OK, this topic is so important that before we leave it, here's a reminder of the rules for special lateral offset procedures. No ATC clearance is required for Slop offsets, neither should ATC be notified. Pilots may apply an offset outbound at the oceanic entry point, but must return to centre line at the oceanic exit point. Aircraft should take account of the positions of aircraft above and below in the same track to avoid collision risk in the event of severe turbulence resulting in inadvertent climb or descent. Aircraft may also offset to avoid wake turbulence, in which case they may coordinate their offsets with other aircraft using 123.45. Offsets must use FMC automatic programming capabilities and must not be flown manually. Aircraft without automatic offset programming capability must fly the centre line. Offsets must be no more than 2 nautical miles and only to the right.